Hi Jobbies. So we will come to the last part of part 1 of the introductory lesson to oscillations. Yeah, so we discussed a lot, and in the previous lesson we discussed a lot about elastic potential energy and velocity as a function of position. So now what's remaining is to get to answer some tutorial sheet questions, yeah, so that we perfect what we learned and trying to see how and where we can apply. So I've been given a 0.25 kg is attached to a light spring, and then it oscillates around on a horizontal table. The oscillation amplitude is 0.125, and the velocity, reading is boring. Okay, yeah, the velocity is 3 meters per second through equilibrium. Okay, so we have we have a spring. So the amplitude of this spring is 0.1. So amplitude is maximum displacement. We defined these terms. So if the distance here is 3, no, 0.125, or if it is stretched when it goes that side, it's still 0.125. So it passed here at equilibrium, or at equilibrium, that's when the speed was 3 meters per second. So the first question is find the spring constant. So here is where you get to analyze things like, okay, they want us to find the spring constant. We have been given velocity and amplitude, and then the value of x we have been given is equal to 1. So when you collect your data and analyze things, you're able to see that, or remember the velocity as a function of time. Velocity as a function of time. So what do we do here? Now we remember it's k over m, and then a squared minus x squared. So this will be equal to the square root of, so let's want to find this, the spring constant. You see it, the spring constant is what we want to find, and then we have everything else, the mass, yeah, we have mass, velocity, this and that. So obviously we can do this. So we're going to say we should make k the subject of the formula. So how do we make it the subject? We start by getting rid of the square root. Yeah. So we have, okay, yeah, so we have this k over m a squared minus x squared. So to get rid of the square root, we simply introduce both sides power 2, and then we cancel. Oh, this 2 cancels with this. Here there's no cancelling. There's no cancelling, so our v squared is equal to, the root has gone away. We have k over m, and then we have a squared minus x squared. Alright, so and then here we just, if you want you can substitute, and then later on you just start simplifying, or you can try making k the subject just here. So you say v squared is equal to k, yeah, so this is multiplying a squared minus x squared over m. So you cross multiply, you're going to have k a squared minus x squared is equal to mv squared. So here these two, they have just multiplied m and v, and then to remain with k alone, I'll simply say over a squared minus x squared, even here over a squared minus x squared. So finally k will be equal to mv will be equal to mv squared over a squared minus x squared. Okay, so and then what's remaining is simply substitution. So when we the mass is 0.25, mass is 0.25, and then the velocity, they told us it's 3 meters per second. So the velocity is 3 meters per second. It has a square. And then amplitude, the amplitude they gave us, the maximum displacement, is there 0.125. That's the amplitude, 0.125. So from here you just get to simplify. What is 3 squared times 0.25? Okay. We shouldn't forget the square which is on A as a square. So on top we have 2.25 over a long number. Alright, so from here we just divide the spring constant. We're getting 144. You put Newton meter. Yeah, so this was the value of K. And then what else do we have? Calculate the total energy of the spring block. Okay, so the total energy of a spring block of this block. So at this point, when the amplitude is maximum, so this is when amplitude is maximum. So we said at this point we only have the energy due to the spring, the elastic potential energy. So because we don't have kinetic here, the block doesn't move. For a moment it will stop, and then that's when it will start going back, and we don't have potential. So the total energy there, total energy, we write it as E. So it is equal to half Ka squared. A is for amplitude. So 1 over 2 times 144, the constant, And then the amplitude, what did they tell us? They said the value of A is 0.125. Okay, so 0.125 squared. So you can finish it up from there. The total energy you are going to get 1.125 joules when you multiply everything. Okay, and then the last question is find the block speed when x is equal to a over 2. And this is a very common question. So they tell you to find the block of the speed. So we're just remembering this velocity plus or minus. So usually we'll get positive unless it is stated in the exam or in any question, unless it's stated that the object was moving to the left. So this is k over m a squared minus x squared. So you can find the value of v. Here k you put 144, here 0.25 you put, and then the amplitude is 0.125. You know it, you can put, and then x, they said you find the value of x if x is equal to a over 2. So this a, since it's 0.125, you divide by 2, then that's your value of x. And then you can proceed. Alright, so we'll end here. You can substitute the values. Yeah, where you are not clear, you let me know. Where you would like to ask for clarity, yeah, you just let me know. So we'll end here, and then the other video after this one will be an example to explain the conservation of energy, and then we move on to lesson 2 later on. Yeah, so for now it's a bye bye. Have a great day.